Our new version of PurityChrom 5.9 offers updates along with new powerful features. In this video, I want to introduce our new feature of defining variable factors for certain functions in a method. Those are called variables. When writing a time control file in PurityChrom, you will now find a tab called Variables in the editor window. Here you can define variable parameters which can be set according to the specific purification just before starting a run. The variable functions you can use are, for example, solvent composition, flow rate, collector position, limiter value, function time, and so on. The default value you put in over here is always appearing before the start of the run, and you can then change it easily according to your needs. I will now show you on how to define variables, use them in creating a method, and how to start a run or sequence with them on two specific applications. The first example on how to use this feature is the development of an universal method for quick and easy column equilibration or washing. Here the most important parameters that need to be considered are solvent composition, flow rate, maximum pressure, and the end time or end volume of the run. You can give them a short name, as you see here on the left side, and a default value, which you can see on the right side. And this default value will be shown before you start the method, and you can either accept it or change it according to your purification or washing task. When now writing a method file, you can use those variables by holding the left mouse button over the space where you want to add the variable and insert it. Here I put in a variable composition of solvent, as you can see here, at the beginning of the method, a flow rate at the beginning of the method which can be variably changed, a threshold for the maximum pressure, and as we always want to have a chromatogram, this is set and is not variable, and in the end volume of this method is also variably set. To set the maximum pressure, you can go to the threshold tab. Here you choose the pressure channel, which is found here, and then you can put in the variable for the maximum pressure by left-clicking the mouse. The start volume is 0 milliliters, and the end again is a variable. And to tell the software PurityChrom what it should do when this threshold is exceeded, you just put in, hold current run, for example, as I want to have it, insert it, and then insert it into the method. The written time control file can now be loaded, and when it's started, the variables list will appear, and according to what column you use, or if you want to wash or equilibrate your system, you can put in here values for your solvent A. For example, if you want to wash your column with 90% A and 10% B at a slightly higher flow rate and higher pressure for 25 milliliters, you can put this in, apply and start the method, which will start running. All changes or all values you put in at first are being logged and can be later on found in the protocol viewer in the reconstruction file. The second example I want to show is how to use the variables in an easy method development. In the method I set the solvent composition at the start and the solvent composition at the end are variables. So therefore you can easily adjust this gradient. Also, I set the flow rate as a variable and the valve position of the column selection valve. Thereby you can easily switch between columns with the same method. Also the wavelength is variably set and the stop composition. One can either run this method as a single run and just adjust the variables as I shown before, or one can use also the newly implemented sequence table which looks like this and is found here in the toolbar. And by loading in 2 different probes, for example, and using our method with put in variables, one can adjust those variables now and therefore do an easy method scouting. For example, for the first one, I want to start with 100% of A and stop at 20% of A, and I want to compare this to when I start with 80% A and go to 5% A. And this is easily done by just running those 2 methods and compare them against each other. One can also think about changing it to another column and comparing this, or changing wavelengths and therefore see which wavelength is the better one. I hope I could convince you with this short tutorial that the variables implemented into PurityChrom 5.9 are a great tool for achieving the best performance with your purification system.